Welcome to the video that's going to talk about the incenter and the inscribed circle of a triangle. So, new vocabulary. Study this vocabulary. If you don't know the vocabulary, you are going to have a very hard time when it comes to actually solving questions that involve these words. So, if you use flashcards, make flashcards. If you have it in a notebook, put it in your notebook. But the incenter of your triangle is the point where all of your angle bisectors meet. So, in a triangle, we have three angles. I'm just going to call them A, B, and C right now. So I know that I can have an angle bisector for A, for B, and for C. So in general, there are always three angle bisectors that you can make, that you can construct, and where all three of those meet, that is called the incenter. Now, another important fact about the incenter, which in this diagram it is right here, the incenter is also the center of the inscribed circle. So make sure you know both of those parts, and we will talk about what an inscribed circle is on the next slide. So another new vocabulary word, the inscribed circle, is a circle that is enclosed in a triangle, and it intersects the triangle on all three sides. And again, we know that the center, so if this is my center, I know that my center is called the incenter. Now, some important things, I want to show you guys a few non-examples, because one super important fact is that we are only intersecting the sides of our circle one time, meaning I have one intersection here, one intersection here, and one intersection here. Now, also, another cool thing that I like to use is the word inscribed kind of sounds like inside. So that's how I remember that my inscribed circle is inside of my triangle. There's going to be some other circles that we learn about, and it might be helpful to have some useful things that help you remember. So inscribed sounds like inside, so I know my circle is within the borders of my triangle. And again, I promised you guys I would show you some non-examples. So in orange, I am drawing a non-example of an inscribed circle. Now I know it's not perfect, I am not an artist, however, what you can see is on each side I'm intersecting this side twice, I'm intersecting this side twice, and I'm intersecting this side twice. So there are way too many intersections here. And also, our whole entire circle is not within the borders of my triangle, so that is completely not okay. Now another non-example, let's say I have a circle that looks something like this, and I say, hey, there's my inscribed circle. Nope. Not true. So while the triangle, yes, it is enclosed within the triangle, it's within the borders. However, there are no intersection points here. We need to have one intersection point for each of our sides. So this is a non-example. This cannot work. All right, so let's get into applying some of these definitions into our question. So it says the angle bisectors of triangle JKL are JQ, which is here, KQ, which is here, and LQ, which is here. It says they meet at a single point Q, so we know that that point Q is the incenter. And I'm going to cross out these side lengths. We're not going to deal with the side lengths right now. We're only going to deal with the angles. So a super important thing that we do is we want to make sure we are labeling where our angles are at. So it says angle MJP, which is this entire angle here. That is 42 degrees. And then we have, let's use a different color. Let's use this orangish color. We have that PLQ is 18. Now PLQ is only this small region right here. So make sure we are going slow when we are labeling. Now it wants us to find angles PLN and angles NKQ. So let's first find angle PLN. Let's do that in pink. So angle PLN is this pink angle right here. Now, again, we need to know our vocabulary. It tells us that LQ is an angle bisector. Now, I know angle bisectors split my angle up into two congruent parts, right? So if we have that 18-degree angle already marked in orange right here, I know that this side is also going to have to be 18 degrees. Now, to find the angle in pink, all I need to do is add 18 and 18 together, and that would give me 36 degrees. So I know angle PLN is 36 degrees. Now, let's use one other color. Hopefully, I can find a slightly different one to find angle NKQ. So angle NKQ is this angle right here. So we got to try to figure out what we got. Now, in my head, if I know that KQ is an angle bisector, I know that if I find the entire value of this angle, all I'll need to do is divide it by 2. So let's see if I can do that. Now, one super important thing, and let's highlight this. I'm trying to use a bunch of different colors here, but what I do see here is that we have a bunch of triangles in one, but the one that's standing out to me the most is this one that I'm highlighting in purple. And the reason why it's standing out to me is because I have 2 out of the 3 angles. I know that this angle here is 42 degrees. I know that this angle here is 36 degrees, so I can go ahead and use the fact that all angles add up to 180 to help me find what this larger angle is here. So let's do that. So if I did, we can set up an equation, 42 plus 36 plus x equals 180. And then if we combine our like terms, we will get 78 plus x equals 180. And if we subtract, we will get that x is equal to 102 degrees. So again, going back to what this actually means, that means that this entire angle is 102 degrees. Now we don't want that entire angle. We just want that smaller portion that is right here. So to do that, I can take 102 and divide it by 2, and that would give me 51 degrees. Now I know this portion is 51, but then also this other tiny portion in here, that's also 51 degrees. And again, that goes back to the definition of our angle bisectors. We know angle bisectors split our angles up into 2 congruent pieces. So then angle NKQ is equal to 51 degrees. Okay, so these pictures might get messy, but again, just go slow. Try to use all the prior knowledge that you can. And if you have multi-colors pens or pencils, you should try to use those as well. All right, now we're going to get into some construction. So again, the good thing about this is that we already know how to do these. So again, the incenter, we have to construct. It's the intersection of all 3 angle bisectors. We already know how to construct angle bisectors, but for the incenter, we just have to construct all 3 of them, and then we'll talk more about the inscribed circle. But for the inscribed circle, we need our incenter first, and then we can go ahead and make the circle. So in this example, the first thing that we are going to do is we are going to construct the angle bisector of A. So again, first, we need all 3. So let's just do A first. So again, to do the angle bisector, this again should be prior knowledge, but the angle bisector, you first make your reference line or your reference arc, and then what you're going to do is place your needle on one of the intersection points of your arc and your triangle, and you want to make sure you are opening up more than halfway of that distance. I usually like to just do the whole entire distance if my compass allows me to, but then you're going to slightly move your pencil up here, make your arc, switch to the other intersection point, and you're going to make that arc again. Now what you're going to do is simply take your straight edge and go from your vertex all the way through your intersection. So I know that the ray that I just created, that is an angle bisector. Now what I want you guys to do, this is one of the angle bisectors, but to construct the incenter, we need to construct the other 2 angle bisectors, and that intersection point will be our incenter. So pause the video, try to do the other angle bisectors by yourself, and then come back when you are ready to check your work. So now let's do the angle bisector of B. So again, first things first, I need my reference arc, and my reference arc should touch my triangle twice. My needle is going to go on that intersection point there. I'm going to make sure I am open to more than halfway, but again, I like to just go the entire distance. I like to put my needle and my pencil on the intersections if my compass opens wide enough for it. And then without changing the width of my compass, I'm making an arc up there and making an arc here. Now, if my arcs don't intersect, that means I need to go back and extend them, and if so, that's fine. And then our last step is to, with our straight edge, draw a line that goes from our vertex straight through that intersection. And again, I know that this is an angle bisector. So far, I see that my first bisector of A and my angle bisector of B, they're intersecting. So I need to do one more, though. I'm not done yet. I need to do all 3. So let's do angle C in purple. So again, our first step is to create our reference arc that touches our triangle 2 times. We put our needle on that intersection, make sure we are more than halfway. And if your picture might start to get messy here because a lot of stuff is going to overlap, but that is okay. You just want to go slow, make sure you're going step by step, and try not to lose yourself along the way. All right, wonderful. So there's my 3rd angle bisector. Now, what we see is that all 3 of the bisectors that we've created are intersecting at one point. They are all intersecting right here. Now that point is called the incenter of our triangle. But now to construct the inscribed circle, what you need to do is, we know that the incenter is going to be the center of that circle, right? So you place your needle on that intersection point, and then all you need to do is find what your radius of your circle is. So I like to just go straight down, and my pencil is going to just intersect that side. And then what you can do is just make your circle, and it might be a lack of my technology here. Maybe I just need to extend it a little bit. But your incenter should touch each side of your triangle one time. If there's a little bitty space, like over here is a little debatable, that's okay. But for the most part, we have 3 intersection points, and our entire circle is within the borders of our triangle. So this here is our inscribed circle. So again, remember, if the question tells you to construct your inscribed circle, you first need to do the incenter, and then you can create your circle.